Hello everyone. This video is to give you guys a little bit of guidance on the free response for Unit 9 review. So my recommendation, I have a couple of recommendations. Number one, I would do this in chunks. If you sit down to do this all at one time, I think, well, I know because I sat down to do it this afternoon, it's a lot to do at once and it feels very overwhelming. And it might just be me. It might just, I might just be feeling overwhelmed. But I would recommend that you do a problem a day or a problem every other day, or to at least take breaks, because you have 6 problems regarding experiments and they're all pretty long and they all require some writing. So remember that the due dates from here on out, at least until May 25th, at least until your exam, are very fluid. So you want to make progress every day. I am reluctant to tell you that due dates are fluid, because I don't want you thinking that you can leave this off until you get closer to the test, because you absolutely cannot. You have to make progress every day. You have to be working on stats every day. If you wait until the week before, it will be a very painful process, and I don't think it'll be enough for you to be ready for your exam. So, that being said, due dates are fluid, which is why I'm saying maybe do 1 a day or 2 a day until you're done. So, just know that as I go through this video is probably going to be a little bit longer. So my expectation is that you're going to chunk it up and do it at your own pace. The other thing is that I put these free response problems in the packet with the intention that you would solve them on a separate sheet of paper. So all of my responses are typed out, and I typed them out because I find the process of writing these free response very cumbersome, but it's easier for me if I type it up. One thing to consider when I say that I find it very cumbersome is I've taught all of these lessons over 20 times, and I have done these problems more than once. I redo them every year because even though I know the answers, you can't just not do something for a whole year and then expect to be perfect at it. So I'll go through and do these solutions. And I think maybe part of why I find it so cumbersome is because I've done them before. So I'm hoping it's not as cumbersome to you. And I don't mean to put you in a negative mood at all about it. It's doable and it's worth it in the end. Like when you get your college credit, it's completely worth it. And I think the amount of writing is doable. It's just cumbersome for me. So I typed them out on a separate sheet of paper. So that's one of the reasons I didn't give you space in the packet to work out your free response. You're going to want to do them on a separate sheet, and feel free to type them up if you would prefer. Okay, that's a 4-hour-long intro. I apologize. Let's head into number 1. This problem is wanting you to address the language and the principles of design. So it's about a tractor pull. They're saying that the amount of energy that you need to pull the tractor is called draft. And draft is affected by environmental conditions such as soil type, terrain, and moisture. So if you really think about that, if you're trying to drag something through mud, I bet you that takes a lot more energy than dragging it through dry dirt. So when they say that the draft is affected by the soil type, I want you to keep in mind that what they're really saying is there are environmental factors that will affect the energy it takes to pull the plow through the dirt. So I'm just going to make a little note to myself here that says dirt versus mud. And that specifically applies to that one part of the problem. So there is a part that connects your hitch to the tractor. or no, sorry, the plow, my bad. The plow to the tractor. So they're separate pieces, and that's called a hitch. Like some cars have hitches on them. There's going to be a study to determine whether a new hitch can help reduce draft. So they're thinking that maybe this new component will make it so that you don't have to expend as much energy to pull the plow through the dirt. So they are comparing a new hitch, newly developed hitch, compared to a standard hitch. And they're hoping that the newly developed one will reduce draft. 2 large plots of land were used in our study. They are going to randomly determine which plot is plowed with the standard and which one is plowed with the new one. So I've highlighted some information here that I think is going to be very helpful in answering the questions. So they have a new hitch. They have 2 plots of land. They're going to plow one plot with the new hitch, and then they're going to plow another plot with the standard hitch. They're going to use the same tractor to pull the plow. So they'll do one, unhook the tractor. I think I'm saying that backward. They're going to use the same tractor on each, because the tractor is what pulls the plow. Sorry about that. So they're going to plow one plot of land. They're going to take the actual plow off the tractor, trade the hitch, reconnect them, and plow the other plot of land. That's what they're describing here. And then to determine if draft was decreased, they are going to take 25 measurements while they're plowing. So while they're plowing the plot, they will randomly select 25 times that they're going to record the draft or the amount of energy it takes to pull the plow through the dirt. Okay, sorry that was such a long setup, but sometimes to solve these problems, you have to really understand what the problem is telling you. So part A, what is the response variable? So the question is, what are you measuring? And I just said. Feel free to pause and fill this in as I'm going. Part B, identify the treatments. So what are you assigning? And that goes along with C, to the experimental units. So they want you to identify what are the treatments that you will assign to the experimental units. So B is what are the treatments. C is what are the experimental units. So who are you assigning to? And I say that in quotation marks because it's not a person in this problem. You're not assigning anything to a person. So you could say who or what are you going to assign your treatments to? Just to give you a little bit of guidance, there are 2 treatments. There are only 2 treatments. You have to figure out what you're going to assign those treatments to. Part D. Given that the goal is to determine whether the newly developed hitch reduces draft compared to the standard hitch, was randomization used properly in this study? Justify your answer. So they're making it seem like this is going to be a long, drawn-out answer, and it's not. All they're asking you was, is there random assignment? So you will say, yes, they randomly assigned blank to blank, or no, there was no random assignment. E. Given that the goal is to determine if the newly developed hitch reduces draft, was replication used properly in this study? So as a reminder, on page 911, it goes through replication. Replication is the principle of assigning many subjects to each treatment group. So, many subjects to each treatment group. Did you have replication in this study? So either you're going to say yes, because I assigned blank to each treatment group, or you're going to say no, because I assigned blank to each treatment group, and in that blank goes a number. And then F is connected to part E. So if your answer in E does not lend you to talk about confounding, then your answer to E is wrong. So it's connected to part E. It's saying plot of land is a confounding variable. Well, remember, a confounding variable is when we don't know if it is this or that that caused the reduction in draft. So what they're saying is we won't know if the land caused the reduction or the new hitch caused the reduction. So that goes back to this that I started with. We know that there are going to be environmental factors like moisture in the dirt, the terrain, the soil type. Like some parts of our yard have soil that's like clay, and then other parts of our yard are like weird, brittle sand clumps. So the terrain can be different. The soil type can be different. So what if you get one of the pieces of land is very easily plowed, but another piece of land has a bunch of rocks in it? That can be a confounding variable. We won't know if it's the new hitch or if it's the type of land that led to the response in your draft. Okay, that's question 1. See what I'm saying about chunking it up and coming back when you're ready? Question 2 wants you to assign these wells to a treatment group. So we are going to investigate whether a filter will clean the arsenic from private wells. They want to know, I believe, if it's a newer filter does a better job of cleaning the arsenic from the water. So I've highlighted the things that I think are important to help you solve this problem. We're investigating the effectiveness of a new filter compared to an old filter. We have 8 wells, but we want to make sure that we're noticing that 4 of them are up against a granite ledge and the other 4 of them are up against a burned forest. We are going to divide each, sorry, I'm just reading this. We don't need to know that next part. And then 1 filter will be used in each well. So we're going to take these wells, we're going to assign half of them to the new filter and half of them to the old filter. So this is a diagram of what they're describing up here. So they're saying the company will use 4 of each type of filter to conduct the investigation. That's what I just was describing. You will assign half of these wells to the new filter, which would be 4, and half of them to the old filter. Assuming that there is a difference in effectiveness for the 2 filters. So they're saying, assume that there is a difference, and we're trying to recognize that there's a difference. What conditions will a randomized block design be better for detecting the difference than a completely randomized design? Could there be, so my advice to you or help is, could there be significant differences between the wells? Well, family, let's go back up here and investigate where these wells are. I would imagine that these wells that are like by the burned forest probably have worse water quality than the wells that are by the granite ledge. So could there be a significant difference between the wells? Yes, there is. That difference is what the well is next to. So we would want to block because there is a difference in the wells. If we just use a completely randomized design, you may end up with 3 of these wells in one group and 3 of these wells in the other, and then you won't know. Did my filter not work better because I had a bunch of the burned forest wells, or was it because the filter isn't great? So, why would we, or under what conditions would we use a randomized block if there's significant differences between the wells? B, identify the wells by number that will be included in each block. So they're saying they want you to explicitly say, I will block by, or I will use blank as my blocks. Block 1 will be the wells you list. So maybe you're going to use 2, 4, 6, 8 in your first block. Block 2 will be 1, 3, 5, 7. Just so you know those blocks are wrong. If you have those numbers, you didn't do it right. So they want you to explicitly list what is your block, what is block 1, what is block 2. C, describe how to assign the filters to wells to create a randomized block design. Write it out. Draw a picture if you'd like it to go with your written response, but you need to write it out. I was kind of shooketh by how many of you guys just drew a picture on your practice exam, because you guys had plenty of time to write out the process on your practice exam. So remember, you only draw a diagram when you're like, I am going to run out of time and I know that there are other answers that I can work on. So you scribble that drawing down and go on to the next. But if you have the time, you need to write it out. And in this problem, the expectation is you are writing out how you would assign these wells. Question Question 3, people with acrophobia. This is a fear of heights. So they're going to compare the drug D-cyclosarin to a placebo, I think it is. So, was this study an experiment or an observational study? Provide an answer or provide an explanation to support your answer. So on the very first page of our notes for this unit, I explained to you what the difference between an observational study and an experiment is. An experiment shows causation because we randomly assign treatments. So was this study an experiment or an observational study? The question you're really investigating is, did we randomly assign treatments to these 27 people? B, when the data were analyzed, the D-cyclosarin group showed statistically significantly more improvement than the placebo group. Based on this result, would the researchers be justified in concluding that the D-cyclosarin pill and the 2 therapy sessions are as beneficial as 8 therapy sessions without the pill? So before I move forward, I did not explicitly describe what is happening in this problem because it took me so long for number 1, and I'm realizing that I don't want this video to be an hour and a half long, so I'm not going through every single problem, the setup of every single problem like I was before. Maybe I should. So, if you haven't yet, okay, you guys are going to be so annoyed with me. So, people with acrophobia are people that have fear of heights, and sometimes they enroll in therapy sessions to help them overcome this fear. Typically, it takes 7 or 8 sessions needed before you see any improvement. So they're saying typically you have to go to your therapy session 7 or 8 times. A study was conducted to determine whether the drug D-cyclosarin used in combination with fewer therapy sessions would help overcome this fear. So they're saying, hey, this usually takes 7 or 8 sessions. Let's see if we can cut it down by giving them a drug and only doing a couple of therapy sessions. So we have 27 people that are participating in the study. 27 people received a pill before each of 2 therapy sessions. So these people are only doing 2 therapy sessions. They're getting a pill and then doing 2 therapy sessions. 17 of the 27 people were randomly assigned to receive the D-cycloserine, and then the remaining 10 received a placebo. So both groups take a pill and then do 2 therapy sessions. One of the group actually has D-cyclo, the other one has a placebo. After the 2 therapy sessions, none of the 27 people received additional pills or therapy. So that's all they did, the D-cyclo and the 2 therapy sessions. 3 months after the administration of the pills and the 2 therapy sessions, each of the 27 people was evaluated to see if he or she has improved. So now we're back to part B. Can we compare the study with D-cycloserine and 2 therapy sessions to the 7 or 8 therapy sessions that's the standard approach? And the answer is no. So you need to figure out why the answer to this is no. Why can't you use this experiment to conclude that D-cycloserine and 2 therapy sessions is as beneficial as 8 therapy sessions without a pill? So the answer is no. Now you need to figure out why it's no. And the key is, look at the experiment and look at what you were comparing. So the 2 treatment groups, what 2 treatment groups were you comparing? Were you comparing D-cycloserine and 2 therapy sessions to a group that did 8 therapy sessions? Because if you wanted to be able to make the conclusion they're making, that's the comparison you would have had to make. If that didn't make sense, rewind and watch it again. Okay, part C. A newspaper article summarized the results of this study. That summarized the results, did not explain how it was determined which people would receive D-cyclo and which received the placebo. Suppose researchers were allowed to choose therapists. Oh my heavens. Suppose that the researchers allowed the therapist to choose which people received D-cyclo and which received the placebo. So no randomization was used. Explain why such a method of assignment might lead to an incorrect conclusion. Confounding. If you allow your therapist to choose who gets what, there probably is going to be some level of influence. So what if your therapist chose to give the medication to the more severe cases of acrophobia because they're assuming that the pill will work, and then they give their less severe patients the placebo because they're not suffering as much as the other group? That could lead to confounding. Is that the only scenario? No. But is that a potential scenario for confounding? Yes. Because we wouldn't know if it was truly the D-cycloserine that helped the patients, or if it was the fact that they assigned the medication to the most severe group and the placebo to the less severe group. So, number 4. A researcher wants to conduct a study to test whether listening to soothing music for 20 minutes helps to reduce diastolic blood pressure in patients with high blood pressure. This is compared to simply sitting quietly in a noise-free environment for 20 minutes. 100 patients with high blood pressure at a large medical facility agreed to participate in this study. So we know these 100 people have high blood pressure. Half of them are going to sit in a room and listen to soothing music, and then the other half will do noise-free. I have a really hard time saying the word noise. I want to say noise. Propose a design for this study to compare the 2 treatments. So let me give you a hint here. the best is to do some kind of matched pair. And you can do it either way. You can do it like the GPA and the SAT problem, or you can do it like the diet problem where we had our people do one treatment after the other. So either matched pair that we've talked about, you can do. Or you can do a completely randomized design, which would be 2-hat method. You might even be able to block based on gender. They just didn't put that in the key. I'm pretty sure you would get full credit. So the best, matched pair. Completely rando is always acceptable if they don't tell you exactly what they want you to do. If you want to do completely randomized block, gender would be a good block. B. The null hypothesis for this study is that there is no difference in the mean reduction. So then they go on to describe what happens and want you to talk about a type 1 and a type 2 error and the consequences of each in this study. So remember, type 1 has to do with hypothesis 1. So hypothesis 1 is the null is true, but you reject. Type 2 is that the alternative is true, but you fail to reject. When you come up with your consequences, you just do what you think makes the most sense. Because I bet you I'm going to get 15 different answers, and as long as you explain yourself clearly, you'll get full credit, and they could all be different. So I'm not really going through this one. If you need help with it, though, I'm happy to help you in class or send you a video message or whatever you might need, so just let me know. Oh, hallelujah, we're on the last page. Number 5. There have been many studies recently concerning coffee drinking and cholesterol level. While it is known that several coffee bean components can elevate blood cholesterol level, it is thought that a new type of paper coffee filter may reduce the presence of some of these components. The effect of the new filter on cholesterol level will be studied over a 10-week period using 300 non-smokers who each drink up to 4 caffeinated cups of caffeinated coffee per day. Each of these 300 participants will be assigned to one of 2 groups. The experimental group, who will only drink coffee that has been made with the new filter, or the control group, who will only drink coffee made with the standard filter. These guys drink a lot of coffee. Each participant's cholesterol level will be measured at the beginning and the end of the study. So A, describe an appropriate method for assigning the subjects to the 2 groups so that each group will have an equal number of subjects. I would use 2-hat method. Boom. B, notice that it doesn't say it has to be completely randomized, so you don't have to do 2-hat, but 2-hat is the easiest, in my opinion. B, in this study, the researchers chose to include a group who only drank coffee that was made with the standard filter. Why is it important to include a control group in this study, even though cholesterol levels will be measured at the beginning and the end of the study? So you want to go to your notes where it talks about control group and describe what a control group allows you to do. So, B, you need to go and look up control group. In this study, the standard filter was the control group. So what is the importance of a control group? I don't remember doing that. Let me double check my answers real quick. Okay. So just a little hint with that one is that it helps with confounding. If you have a control group, it helps with determining whether the difference is caused by the treatment or something else. C, which test would you use? Skip. Skip C. You do not have to do C. D, why would the researchers choose to only use non-smokers in the study? Confounding. I would imagine that people who smoke have a higher cholesterol level. So, B, control group helps with some confounding, and D, confounding for sure. 6, a biologist is interested in studying the effect of growth-enhancing nutrients and different salinity on salt levels. Okay, so A, list the treatments that the biologist plans to use in this experiment. So I did two things here. Number two, why would I start with number 2? Number 1, I drew the table. So you have 2 factors. One factor has 2 levels, the other factor has 3 levels. And then, once I drew the table and figured out what my treatment groups were, I actually listed them out. Like, I listed nutrient A and low salinity, nutrient B and low salinity, nutrient C and low salinity. You can do one or the other. You can draw a table, or you can list them out, or you can do both. So one or the other or both. B, using the treatments listed in Part A, describe a completely randomized design that will allow the biologist to compare the shrimps. So this one is actually a good candidate for 2 HAP method, because your number of treatment groups are smaller. So it is realistic that you could actually do 2 HAP method in Part B. Sometimes it's not realistic, but it's the easiest one to describe. C, give one statistical advantage to having only tiger shrimps in the experiment. Well, if you only have tiger shrimps, then you don't have any confounding with other types of shrimp. So that's one advantage. If you include other types of shrimp, then you could have confounding, and you wouldn't know if it was the growth nutrient and the salinity that affected the shrimpies, or if it were the breed, do shrimpies have breed, or the kind of shrimp that it was. So a statistical advantage would be you eliminate confounding based on the type of shrimp. And eliminate is the right word to use, because you're not using any other types of shrimp. D, give one statistical disadvantage. Well, the disadvantage is now you only know about tiger shrimp. You can't say anything about any of the other shrimpies, just the tiger shrimpies. Okay, 7. Researchers investigated the possible beneficial effect on heart health of drinking black tea and whether adding milk to the tea reduces any possible benefit. So they're going to put these volunteers into 3 groups. One group is going to drink hot tea without milk, one group is going to drink hot tea with milk, and one group is going to drink 2 cups of hot water. Did the researchers conduct an experiment or an observational study? Well, was there random assignment? That's what you're addressing. If there was random assignment, then it's an experiment. If there wasn't, then it's an observational study. B, why did the researchers include a group who drank hot water but no tea? That's your control group. And you need to write more than that's your control group. You got to write some more things that show you know why that's your control group. And C, is it reasonable to generalize the results of the study beyond the 24 participants? So the question here is, did these guys, were they randomly selected or did they volunteer? So for these guys, were they randomly selected or did they volunteer? If they were randomly selected, then you can say So let's say you chose to do this study with 20 to 30-year-olds. If these 24 people were randomly selected from the population of 20 to 30-year-olds, you could say, for 20 to 30-year-olds, drinking 2 cups of hot tea with milk does blah, blah, blah for your heart health. However, if these 24 people volunteered, then the results only apply to the 24 volunteers. And what you would say is, a study based off of a group of 24 volunteers showed that drinking tea with hot milk, blah, 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 heart health. And it's a very important question that you're asking here. So, can you generalize to all people, or can you only generalize to the 24 people? All people if they're randomly selected, just the 24 if they volunteered. That's that. I will make a video of solutions. I will put that on a flash drive, and then I will only give that to you after you turn in the solutions. Oh, teacher. After you turn in the solutions to me so that I can grade them and gauge where you're at. So, I would not wait very long to do this so that you have time to redo it and get an A if that's what you're hoping for. Okay. Love you guys. Hopefully that was helpful.